Before we start, I'd like to make sure, please check that you're all muted. Well, for those of you who don't know us, ERBE and LoLo are two centers for doctoral training focusing on energy systems and the built environment. And the main institutions involved are UCL, Loughborough University, and we were recently joined by MaREI, which is a research development and innovation center in Ireland. Before we start, I'd like to briefly introduce you to the team who has organized the conference with me. That's Charlotte, Nikki, and Ahmed. They're all in this call. I think they have their video on, so if you could wave, everyone will know who you are. Yeah. But they'll guide you through the Q&A, so you'll meet them later. Some best practices I wanted to share at the beginning of this conference, so that we can make the best out of it. So I'd like to ask you all to keep your video turned on, as this allows for a more real-life experience. But we are recording this conference and are planning to share it afterwards. So if you don't want to be in the recording, I'd just like to ask you to don't have a very active role in this conference. For any technical issues, please use the Zoom chat. For all questions for our presenters, we have created a Slido. You can see on the right side of my slide, you can see the Slido event code. So if you just type that in, you'll get to the Q&A window. So because we are using Slido quite a lot in this conference, I'd like to test your Slido skills. So if you could all just go to Slido and type in LoLo ERBE conference as the event code, and let us know by just typing in the field where in the world you're joining us from today. I'll give you a minute to do that, and I will also show you how you can do it. I'll change my screen. I go here, so you should now see a window open, my Slido window. So if you're in this window, just type LoLo ERBE conference. You should get straight to the Slido, and just let us loading a bit slow. But if you type in here where you're joining us from today, so I myself am in Germany. So I'll post that, and then we can see quite a lot of people from London, but wow, even from Japan, India, that's very impressive. So I'll leave that on for a bit longer. In the meantime, we'll move on, but you have the chance to just post where you're joining us from today. So let me go back to the presentation. Right, so back to the next slide. Before we start, for all of those social media savvy people, don't forget to tweet about our conference and help us to share the research our presenters are doing on social media. You can use either our LoLo Twitter account, the LoLo conference, or just use the hashtag LoLo ERBE conference. Right, let's have a look at the timetable. We will start with a short introduction by Professor Robert Lowe, who is the director of the ERBE CDT. This will be followed by our 5 student presentations, and we will then hear a keynote speech by Professor Mark Gillett, and we're very excited to welcome him today. There will be a Q&A session once all 5 student presenters have completed their presentations. So please post your questions on Slido throughout their presentations. We'll get back to them at the end. And yeah, use the LoLo ERBE conference hashtag and the event code. Depending on how many questions we have and how much time we have left, we'll allow participants to ask questions themselves by unmuting. So please, when you submit a question, write your name, affiliation, and which speaker the question is for. If you would like to ask the question yourself, please just add an exclamation mark. Otherwise, we'll read the question out loud for you. And here on the right side on my screen, you can see how this should look like. So you have the Q&A, and you can just post your question. And also on the same page, you have the polls. If we have too many unanswered questions after a Q&A session, we have asked all our speakers to stay logged into this meeting a bit longer. So there will be 20 more minutes after the conference has finished to ask your question in person in a bit more informal chat. So if you would like to do that, just stay on in this meeting after 3. And right before, I just forgot one little thing before we move on. I'm missing, oh, Yeah, that's fine. So now, sorry about that. We're now going to hear a little welcome speech by Professor Robert Lowe. Bob, are you in the meeting? Can you hear me?
Hi, Anna. So Bob is having a little bit of trouble joining at the moment, but we'll hopefully have this sorted in the next 2 minutes. But if everyone could just hang on for 2 minutes, I will try and get Bob on the...
That's fine. I can explain in the meantime the little competition we have prepared, if that's fine.
Yeah, that's a good idea. Thank you.
So let's move here. Right, so we haven't activated this poll yet. For now, you can just fill in where you're joining us from today, but we prepared a little competition to find out the best presentation of today's conference. So yeah, once the poll is activated, you can, on Slido, the page will, I think, come up automatically. You can vote for the best student presentation, and they will even get a little prize. So again, same Slido page, same hashtag, and yeah, there you'll find all options you can vote for. So while Nikki's sorting out how to connect Bob to this conference, let's have a little look at where you are joining us from today. If we can share the screen just to see the updates. London, Loughborough, Manchester seems to be one of the most favorite places, but it is quite international, which is very nice to see. I guess this is the advantage of these online meetings. Usually it would be an in-person conference, but given the circumstances, this is our best option. Let's see if Nikki can sort this out.
Hello.
Yeah, we can hear you.
So Bob is having a bit of trouble, but what we figured we could do is I'm going to get the slides up and then put Bob on my speaker on my phone, and he's just going to talk us through it. But he said give him just 2 more minutes for him to try and figure out the Zoom himself, and if not, we'll do the speakerphone thing. Is that okay?
That's fine. I'll guess some people might still be joining. So let's maybe just wait and follow the Slido poll.
Hi everyone. So we've decided to go for the speakerphone option. Sorry again. And I'm going to share Bob's slides with you right now. If you just hold on for 2 seconds. How's that? Can you see something?
Yeah, we can see it.
Okay.
The first slide up.
Okay, yeah, Bob, you are on now, and the first slide is up.
Can people hear me?
We can hear him.
I'll assume yes. Nikki will stop me if cannot hear me. So the first thing I'd like to say is how glad I am to be able to welcome all of you to the LoLo ERBE student-led conference. I believe this is our seventh conference, and I have every expectation that it will be the best and most successful yet, despite being held under such unusual circumstances. So I've just got a few slides to run through just to set the scene. If we can go to the second slide, Nikki.
Yep, we're now on the second slide.
Excellent. And what you will see here is I hope you have all downloaded and read this report from beginning to end. It's the front page of the Committee on Climate Change's Net Zero report. And there are just 3 things to say here. First of all, net zero is a very big deal. It turns out, as far as we can see, to be significantly more challenging than 80% and much more challenging than the previous target, which was introduced in 2003, which was 60% reduction in greenhouse gas emissions. But it is the correct target to be using. The other targets were only ever stopgaps. This one is the first one that, in my opinion, makes complete sense. Moving on to the next slide. I want to say a few things about change. One of the easiest mistakes for human beings to make is to assume that the future will be just like the past. We do it all the time. All of us do it all the time. This slide is taking a backward look over most of the last century, just how much change there has been in the energy system throughout the 20th century and into the first decade or so of the 21st century. Change is normal. Change happens all the time. We just don't always notice it. Moving on to the fourth slide, Nikki. This is zooming in on one particular aspect of change, which is the carbon intensity of UK grid electricity since 2020. And you can see that emissions for UK grid electricity is not that preposterous an idea if you take the long picture. Carbon emissions have come down steadily. I wouldn't say exponentially because it's more complicated. But carbon emissions, carbon intensity of UK grid electricity has been falling steadily. And indeed, we have now pretty much passed the point where electricity is less carbon intensive even than natural gas. This turns the whole energy system on its head. Moving on to the next slide. And Nikki, this one is animated, so you will need to step through. So what we have here is a projection made by the CCC in 2008 of where the carbon intensity of UK grid electricity would go. And I hope you can all see the little cross below the graph, below the CCC's graph. That is the actual carbon intensity of the grid electricity in 2019. When I first saw this graph, I was astonished that any respectable organisation would produce something so optimistic, and yet the outturn has been even more optimistic than I feared it might be. Moving on to the next slide. The big change that's happened over the last 3 or 4 years is in wind and solar prices. And this little slide just plots the development of offshore, in particular, offshore wind electricity prices and solar PV. And moving on to the next slide, what we have here is a little thumbnail looking at the interplay between energy demand and energy supply. It's conceptual only, but it illustrates the principles that are at work, that at some point the supply curve and the demand curve have to meet, have to cross. If we believe in optimality, finding the optimum balance between demand and supply as it were, the guiding principle behind energy policy, then our most important task and your most important task as budding experts in the area of energy is to work out where that crossing point is going to be. But finding that crossing point turns out to be very difficult. Moving on to the next slide, slide 8. The point about the previous slide is that action on energy demand will only get us so far, because almost all actions in the area of energy demand face increasing costs as you shave away demand. Conversely, supply, at least over the last 10 or 15 years, appears to have been getting cheaper the more of it we decarbonise. There are significant problems on the demand side of the economy, what I refer to here as dense webs of socio-technical constraints, particularly in buildings. There is comparative simplicity on the supply side. So, what is the task of people who are investigating and researching energy demand? One of the most important tasks is to try to find a way to join up, and I'm moving on to the next slide now, Nikki, slide 9, is to coordinate actions on the supply and the demand side of the economy, so that, for example, decarbonising electricity has something to connect to in people's homes, in businesses, in commercial buildings, and so on. Joining up the whole of the energy supply chain is going to be, I would argue, perhaps the most important task for the next 30 years. The rate of change that we're seeing now in the economy, in the energy system, is, I think, absolutely unprecedented, and it's almost impossible to keep up with all of it. One of the consequences of that is going to be that there is going to be, inevitably, significant muddling through, in contrast to coherent policy, over the coming decades. You, as practitioners and researchers in the area of energy demand, will have to learn to expect the unexpected. The most important thing, and the thought that I want to leave you with, is that there is going to be an enormous need for intelligent, knowledgeable, and above all, flexible people over the coming 10, 20, and 30 years. With that, I want to end my presentation. I want to wish you all an exciting, informative, fascinating conference. I'm sure it will be. In previous conferences, anything to go by. Welcome all of you, and all the very best for the next 2 hours.
Great, thank you, Bob.
Thanks a lot, Bob. I'm going to share my screen now again. You should see my slides. So, mindful of time, I think we could just move straight to the first presenter. But before I do that, just a quick reminder: I've now switched the Slido polls, so you can all vote for the best student presentations. You can do that throughout like the next 40 minutes. Don't forget to post your questions. We will get back to them at the end of the 5 presentations. So yeah, let's hear from our first presenter. It's Joe Pemberton from Salford University. Joe, I'll stop sharing my screen now. If you could share your screen, and also don't forget to unmute yourself.
Hello everyone, can you hear me?
Yeah, we can hear you.
Oh, great. Excellent. So,
we can also see the slides. Perfect, thanks.
Good. Hello, I'm Joe Pemberton from the University of Salford, and I'm studying structural thermal bridging. And today I'm going to talk about my experiments, really, and how I characterize 3-dimensional thermal bridging and calibrated finite element heat transfer models to quantify structural thermal break products in controlled laboratory conditions as a testbed for future in situ assessments. So, in a nutshell, I'm aiming to explore the techniques quantifying the thermal effects of structural thermal breaks in situations. And to do that, I need to meet a few objectives, including understanding the measurements I need to take and the model calibration techniques in laboratory conditions for the future on-site assessment of these as-built details. Now, that said, I'll give you a bit of an overview. I'm engaged in an iCase PhD sponsored by Farat Isolevel, who are a manufacturer and supplier of structural thermal breaks to the construction industry. The research title is an exploration of the modelled and the measured thermal characteristics of these products. So as such, we can split it into 2 distinct sections, measurement and modelling. Now, the measurements we're taking are surface and air temperature readings and heat flux measurements, and these are common in building physics. And we'll be taking these on and around the investigated detail to both verify the wall transmittance theory and for model calibration purposes. Now, if we're windowing data over a representative period and then using the average values to set up simulation models, where the geometry will be meshed and created, and then after applying the boundary conditions and material properties, which we gather from the measurements and the manufacturing details, we'll start the calibration iteration. Now here we'll iterate the simulations by adjusting the model parameters within their sensible ranges in subsequent iterations until the probe values in the model match the measurements in reality. So when we've realized the calibrated status, we can apply standard assessment procedure calculations which are laid out by international standards and the British Research Establishment, which quantify the thermal bridge transmittance, and we can apply that to the calibrated digital twin, if you like, of the investigated detail. Then after, we can tune the experimental design for the assessment of these breaks in situations, and we will have done that by highlighting the foibles before adjusting the acquisition methods around this analysis of this type of thermal bridge. But going back to the basics, the thermal bridge is a weak point in the building's thermal envelope, which allows the heat to bypass the insulation layer. And they can categorized into two generalizations, really. They're linear and point bridging, which exhibit two-dimensional and three-dimensional effects, respectively. But in general, they increase the heat loss and they cause an increased risk of condensation. An example of linear bridging can be seen in the top right-hand corner there, and that shows the complex two-dimensional heat pass through a geometric thermal bridge, which is in the corner of a room. Now, in this case, the phenomena is caused by a large difference in the heat absorbing and the heat emitting surface areas. But other examples of linear bridging are windows and doors and floor junctions, essentially any bit of detail which acts over a length in the facade. Whereas point transmittance acts at direct points and their penetrations of the insulation layer, and they cause three-dimensional heat flows. Now, these solely rely on three-dimensional modeling to predict the point transmittances, and examples include facade anchors or fixings, but in my case, I'm concerned with balcony supports which penetrate the insulation layer. There's an example in the bottom left-hand corner there. Now, to develop my experimental design for in-situ testing, I've got access to the Energy House facility at the University of Salford, which is a unique facility. It's a whole house, fully furnished, pre-1920s Victorian end terrace, which represents around 20% of the UK housing stock. It's a solid brick wall construction with suspended timber floors, so it's a really common construction domestically. But most interestingly is the climatic chamber that it's built in. It's capable of recreating almost any weather condition, achieving temperature ranges between -12 and 30, and it can hold them to within half a degree, which is important to replicate steady state conditions, which is useful in validating theory and testing methods, which is exactly what I did in the preliminary two-dimensional experiment, where we were investigating the corner of a room in the Energy House. And with this, the theory was validated with established measurement methods for this type of bridge, and we did successful model calibration, which we then applied to a three-dimensional bridge. Now, this wasn't found naturally in the Energy House, so we had to conceive it by installing a steel I-beam into the wall. In the bottom left-hand corner, you can see the Farad thermal break solution, which was employed to break the bridging, and that's made of glass and polymer resin composites. It's essentially very hard glass fiber, and it's got the compressive strength of steel and the conductivity of wood, thereabouts anyway. And you can see that it's positioned in between the beam and the wall to mitigate the heat flow. Now, using qualitative infrared, we positioned thermocouples and heat flux meters on the inside wall where this penetration was, and we also embedded heat flux sensors in and around the break detail to gather the heat flux metrics from these crucial locations. 4 phases of measurements were then recorded under steady state conditions. Initially, we did a bare wall, testing it with and without the brake pad, and then we externally insulated the wall and tested it with and without the brake pad. Now, if you look in the bottom right-hand corner, you can see the external wall insulation. It's comprised of soft wall, which was glued to EPS on plasterboard, and this was retrofitted to the brick and chosen in this configuration to eliminate the air gaps, because the soft wall within it would close the air gaps. And it was employed generally to exacerbate the thermal bridging effect, because it's important to note at this point that we just conceived an arbitrary three-dimensional point bridge, and this is not a representative construction detail of where these bricks are positioned in reality, which is why we need to exacerbate the bridging by ensuring the steel beam is attributable to the majority of it. Now, if you look at the chart on the left, we took a sample size of the external wall insulation and I tested the equivalent conductivity at various thicknesses. So that the retrofitted thickness of the external wall insulation could then be interpolated against its equivalent thermal conductivity for model purposes, purposes in simulations. There was another issue with air stratification internally. If you look at the infrared image there, you can see a disparity in the surface temperatures, and this was due to the air stratification. So we rectified this by exciting the flow internally with a fan to ensure homogeneous air mix across the investigated wall. And that graph to the right-hand side shows velocity at the top and temperature at the bottom from 2 locations on the wall. And you can basically take away from that when the fans were on, both velocity and temperature were recorded the same value. So we mitigated the stratification, but I'll get back to this point in the next slide. In the top left-hand corner, you can see that we've improved the thermal contact between the beam and the wall by applying a weak sand cement mix, which mitigates air gaps. And below that, you can see the thermocouple array that was applied to the internal face. And these were used as simulation inputs and responses to calibrate the model, along with the embedded flux sensors in and around the brake. Right. The table on the left there in the blue shows the experimental parameters measured for each phase of testing. The first three were used as input parameters, and they're internal and external air temperatures, as well as the U values. The rest were used as calibration response values. In that, I'm reiterating that the parameters in the model were altered in subsequent simulations until the probe values in the model converged to the corresponding measured response in reality. But we didn't get convergence, I do apologise, we didn't get convergence until I adjusted the surface resistances of the boundary condition surfaces. So going back to the fan issue, in retrospect, since stratification was mitigated using this fan, that would have increased the convection coefficients and reduced the wall surface resistance with respect to the initially employed standardised values. So considering this, we made sensible adjustments to the model and to achieve the calibrated status, to which then we applied the standard assessment procedure calculation to give us the results you can see in the top right hand corner there. Now, you can see that there's been an increase in bridging caused when the external wall insulation was retrofitted, proving that the greater the insulation resistance, the more detrimental the bridge effect. Now, in the first case, with no external wall insulation, when we employed the thermal brake solution, we reduced the transmittance by 4.5%. But in the second case, we reduced it by 17.6% when the thermal brake was employed. So this shows that the better the insulating resistance, the more benefit you can get from using the thermal brake solution. So what does this mean? We've proved the product works, albeit that the calibration status was only achieved by altering the standardized surface resistances. But this strongly informs the decision to measure this variable in subsequent experiments.
The 9-minute mark. Sorry, carry on.
When we investigate, well, the next experiments will be when we investigate the dynamic conditions affecting this type of bridge. But this will hopefully in the end provide bespoke modelling tools for industrial assessments of this type of brake in situation and lead to potentially improved products and or applications. So thanks for listening, and hopefully you can see that from future in situ experiments of these type of brakes, designed using laboratory controlled experiments, is vital in understanding and reducing the performance gap between the as-built and design metrics. I think questions are happening at the end, so I think I'll pass you on to the next speaker right now.
Thanks very much, Joe. Yeah, that's right. Please post questions in the Slido and we'll answer them at the end of the presentations. The presentation session now over to Nicole. Joe, if you can stop sharing your screen, then I think Nicole should be able to start sharing hers.
Great. Can everyone hear me and see my screen?
We can see your desktop background. We can't see.
Okay, I must have shared the wrong screen. Sorry. Give me 1 second. Hopefully this is the right one.
Yeah.
Great.
If you just go into presentation mode now.
Great. So now I've got my presentation rather than a lovely sunset. So thanks very much. I'm Nicole Watson. I'm a PhD student at the UCL Energy Institute. Broadly, my research looks at how the sorry, my Zoom screen seems to be messing up slightly. Let me just move my face out the way. Sorry, my research looks at how business models enabled by decentralized energy are changing the way that the energy market works, the way consumers interact with it, and above all, what consumers themselves think about this. The results that I'm presenting today are from 2 nationally representative survey experiments that look at multiple supply models as a possible enabler of local energy. So just to start with a bit of context, traditionally our energy system has looked something like this, which is a centralized system with power flowing in one direction, energy suppliers acting as an interface between consumers and the energy system, and domestic consumers having contracts with just one supplier at a time. So this is known as the supplier hub model. Increasingly, we're moving towards a more decentralized and flexible energy system with a higher prevalence of decentralized renewable energy sources and lots of new actors in the industry. So this is enabling lots of new business models, for example, local energy suppliers. Oh, sorry, too keen. And these are locally owned energy companies that provide their customers with electricity generated from local, often renewable sources. And in recent years, Ofgem and others have been raising concerns that the supplier hub model could be disadvantaging new market entrants, such as local suppliers, and creating regulatory barriers to innovation. So one proposed solution for this is a multiple supply model. This would enable consumers to have more than one energy supplier. So for example, they could get as much energy as possible from local renewable sources via their local supplier, with their current national level supplier acting as a backup to cover the rest of their demand from the national grid. This would also facilitate other business models, for example, peer-to-peer energy trading or separate tariffs for electric vehicles or smart appliances. So some industry actors have expressed support for multiple suppliers as an effective way of integrating renewable sources into a centralized grid, whereas others have expressed concerns that this might affect consumer engagement in an increasingly complex energy market. There's quite a lot of academic literature that's looked at consumer acceptance of local energy in general, but very little work has addressed multiple suppliers and attitudes towards them specifically. So that's one of the gaps that my study addresses. So we already know that consumer engagement in the energy market is relatively fairly low. Although this is improving, people still rarely switch energy supplier, and among those that do, there's generally a preference for switching tariff with the same supplier rather than trying something new. And understanding exactly why consumers tend to stick with the status quo is likely to have implications for how multiple suppliers could affect engagement with local energy. So one commonly applied theoretical framework in this field is classic economic theory. So this assumes that consumers are rational actors, and when they fail to make choices in line with their best interests, it's due to market failures, so transaction costs, or not having enough information. But there's evidence to suggest that even in laboratory experiments or online, when there are just no barriers to switching and people have all the information they need, people still tend to stick with the status quo. So this suggests that rational choice can't fully explain this tendency to stay with incumbents. So instead, I turn to behavioral economics. This is a theoretical framework that claims we try to make rational decisions, but we also apply these mental shortcuts known as cognitive biases. So in behavioral economics, this tendency to stick with status quo is known as the default effect. So this is the idea that people just don't tend to move away from options automatically assigned to them. In the context of energy suppliers, this could be a tariff that someone's automatically enrolled onto. It could be a contract that someone takes over when they move into a new home, or just a supplier that they've been with for a very long time. We know that defaults have very powerful effects, but there's a bit of contention around why. And in the literature, there's 3 mechanisms that have been proposed. The first idea is cognitive effort. So this is the idea that there's 2 aspects of effort. There's the kind of physical effort of actually logging onto a computer, going online and making the change to switch, but also the cognitive efforts. That's the mental process of weighing up all your preferences and making a decision. Then there's implied endorsement, which is the idea that we stick with defaults because we see them as being recommended to us by the entity that chose them for us. Finally, there's loss aversion, which is this idea that people emphasize potential losses more than potential gains when we make decisions, and we evaluate our choices against a fixed reference point, so the status quo usually. This has been quite frequently cited in supplier switching literature as a reason why people might stay with incumbents. So I argue that these mechanisms have really important implications for how multiple suppliers could affect uptake of local energy. So for instance, if loss aversion plays a really big part in preventing switching to local energy and trying new things, then actually being able to add on a local supplier without giving up your current supplier could potentially mitigate this and drive forth the growth of local energy. But if it's more to do with, say, cognitive effort, then the additional complexity of a second supplier could just increase disengagement. So my study had 2 aims. The first was to understand whether British adults are more likely to engage with local suppliers in a multiple supplier model or the current supplier hub. And the second was to start untangling some of these mechanisms. For this presentation, I'm focusing more on the first aim. So my first experiment had 1,200 participants and was delivered online. This was designed to start untangling some of these mechanisms and look at whether multiple suppliers would be a socially acceptable model. Participants were asked to imagine that they'd received a letter from their current energy supplier that offered them a chance to add on a local energy company's services in what would effectively be a multiple supplier model. They're randomly assigned to one of 3 groups. In the single supplier default group, the current status quo was really emphasized, and this multiple supplier model was framed as a sort of very new thing that they'd have to take action to try out. In the multiple supplier default group, they were told that they had been automatically enrolled onto this multiple supply model, and if they wanted to switch back to their old tariff, they'd have to take action to change. And finally, in the active choice group, both options were presented neutrally, and they had to choose one or the other. Both the options with the default had a pre-tick box to convey this sense of transaction costs. So in the multiple supplier default group, the vast majority of people, when they were told they'd automatically been enrolled onto this new model, chose to switch with it, which is kind of in line with what you'd expect from the theory, but it also shows that people don't have an inherent aversion to these kind of models and that they seem to be, at least socially acceptable. But more strikingly, when people were asked to choose between the two, again, the vast majority chose to engage with this local energy in a multiple supplier model, and there was no significant differences between the two groups. So this shows there seems to be a very strong preference for these types of models. But for me, the most surprising result was the single supply default group. So this is when people had to actively take action if they wanted to engage with local energy. And again, the majority of participants chose to do so. So to me, this is just a really strong preference for multiple suppliers and local energy. I won't talk too much about this, but I did a bit of analysis on which of these mechanisms were at work, and there was the strongest evidence for implied endorsement being associated with choosing this multiple supplier model. Moving on to the second experiment, so this had 800 participants, and again they were asked to imagine they'd received a letter, this time from a new local energy supplier that had set up in their area and were advertising their services. Participants were randomly assigned to either a single supplier condition, which is the current system, so if they want to engage with local energy, they'd have to switch entirely to this new supplier, and any energy that couldn't be provided from local sources would be bought by the supplier from the wholesale market. Or a multiple supply condition where they could just add it on to their current tariff in a similar way to the first experiment. Here the default was doing nothing and staying with their current supplier in the status quo. The results of the second experiment were very different. So in the single supply condition, which is essentially what we have now, the majority chose to stay with their current supplier and did not engage with a local energy company. In the multiple supply condition, so when they can just add it on in this new model, again, the majority chose to stay with their current supplier, but participants were significantly more likely to engage with local energy in a multiple supply model versus the current system. I think it's worth briefly touching on how different the results of the two experiments were. So the study wasn't specifically designed to test the effect of the entity behind the letter, but people were far more likely to engage with local energy when they were approached by their current supplier than a new local supplier. So to me, this suggests that if multiple suppliers are going to be a successful model for driving local energy forward, getting big existing suppliers on board will be key. Overall, the results did seem to suggest that multiple suppliers are very promising for driving the growth of local energy and offering new services to consumers. I'll just end with a quick note on my future research. So the study made a lot of assumptions, and the next steps are to put these to the test. So I'm going to interview policymakers, industry and regulators about the potential configurations of future supplier models. Then I'm going to use a survey experiment to test which aspects of the design of these models really matter to people. So things like whether they receive multiple bills and who's approaching them. The final section of my PhD will try and replicate some of these findings in field trials to see whether the preferences that people say in surveys actually translate in a more real-world environment. I'm also going to look at models beyond local energy, so things like electric vehicle tariffs, peer-to-peer energy trading, and smart appliances. So that's pretty much it for me. Thanks very much for listening, and I'm happy to take any questions in the Q&A section.
Thank you very much, Nicole. That was a very interesting insight also into the future of multiple supplier models. Up next on our list would be Ola from the National University of Ireland.
Yep.
Ola, are you ready to share your screen?
Yep.
And yeah, just a reminder, don't forget to post questions in Slido and also vote for the best presentation.
Okay, so my name is Orla McGinley. I'm a first year PhD student. I'm part of the ERBE CDT. I'm based at NUI Galway, which is one of the partner institutions in the MaREI Centre, Research Centre in Ireland for Energy, Climate and Marine Research. So today I'm going to be presenting a research entitled An Assessment of the Key Performance Indicators of Energy Efficient Retrofits to Existing Residential Buildings. So just a brief overview. I'm going to look through the research context with you. I'm going to briefly go through the methodology that was employed. I'm going to briefly go through the key findings of the study so far, and I'm going to look at some of the main conclusions and the implications of this research. So in terms of the research context, research has clearly demonstrated to date the energy efficiency benefits of retrofitting to existing buildings. However, retrofitting has a wide range of multiple benefits within an economic, social and environmental context. These might include increased property value or decreased operating costs from an economic perspective. This might include energy and emission savings from an environmental perspective, and it might include issues such as improved comfort, satisfaction, occupant well-being, improved health, or fuel poverty alleviations from a social perspective. So ultimately, these wider benefits must be quantified and demonstrated to relevant stakeholders in order to drive retrofit uptake and to drive retrofit investment and to form the basis for retrofit policy design. And additionally, it is held that both the design of the retrofit itself and the design of retrofit policy should aim to maximise some combination of these benefits. It is also important that quality case study data is acquired and used to demonstrate these benefits in order to show what's actually achieved in reality, in order to reduce the risk and uncertainty associated with the retrofit decision-making process from a householder perspective. So the basis of this study was that key performance indicators, or KPIs, are extremely valuable for assessing the wider benefits of retrofit in terms of the performance of the KPIs. So therefore, we have defined and examined a set of economic, environmental and social KPIs for residential retrofits from a householder perspective, and assessed these based on pre and post retrofit data which we've obtained from 5 case study dwellings in the west of Ireland, which you can see on the screen there. So you can see from an economic perspective, the indicators that we've assessed are life cycle cost and payback period. From an environmental perspective, the KPIs that we've assessed include energy consumption reductions and emissions reductions. And from a social perspective, we have assessed any comfort improvements from the retrofit, any fuel poverty alleviations that were obtained, and the householder satisfaction from the retrofit. So in terms of the methodology, the economic benefit was determined by assessing the reductions in life cycle costs that were achieved post-retrofit, or conversely that weren't achieved, and by assessing whether or not the householders received a payback within 30 years. In terms of the social benefit that was attained, comfort benefit was assessed in terms of any temperature improvements or improvements of relative humidity that were recorded within the dwellings. So that was in terms of improvements in the average monthly temperatures, or in terms of the percentage of times that the temperature and relative humidity readings that were taken were either below or above the recommended lower and upper limits for temperature and relative humidity for residential dwellings. So the threshold was about 18 to 26 degrees for temperature and 30% relative humidity, 60% relative humidity for the humidity readings. And then these results were then compared with the occupants' cited thermal satisfaction pre and post retrofit, which were obtained in surveys. Any fuel poverty alleviations were assessed on the basis of the expenditure method. So if the household's annual expenditure on heating fuel consumption was greater than 10% of their income, then they would be considered to be in fuel poverty. So any alleviations that were obtained as a result of the retrofit works in this regard were assessed, and then any future fuel poverty alleviations into 30 years that might be obtained at the post-retrofit levels of expenditure were then assessed as well. And in terms of householder satisfaction, that was determined with a variety of measures of satisfaction. So that would have been with the benefits that they perceived that they have received from the retrofit, their satisfaction with the retrofit process itself, with the quality of the works, or with the hassle or disruption that it caused, the householder satisfaction with the level of contractor engagement in both the design and handover of the retrofit, and their satisfaction with any technologies that were implemented. And then finally, the environmental benefit was assessed in terms of the annual energy consumption and emissions reductions that were not achieved as a result of the retrofit. So as you can see on the screen there, the types of data that were collected for the assessment of these KPIs are shown. So a combination of qualitative and quantitative data was used in the assessment. And so the data collected included pre and post retrofit surveys, temperature, humidity and electricity consumption data, which was obtained from data logging instrumentation that were installed in the houses. And monthly electricity meter readings were taken, oil usage was taken, and estimated solid fuel consumption was also measured. So in terms of some of the key findings, For the economic KPIs, you can see from the table shown that 3 out of 5 of the dwellings achieved economic benefit in the form of life cycle cost reductions post-retrofit. This was a result of the operational energy cost savings that they received, outweighing the capital costs of the works. The life cycle cost increased in 2 out of 5 of the dwellings assessed, and this was attributed to the fact that there was increased energy consumption in these dwellings as a result of post-retrofit. And then in terms of the payback period, the economic benefit for 3 out of the 5 dwellings is also reflected in that they received their payback within 30 years. And if you can see in the bottom right of the screen, that shows a sample of results for one of the dwellings. You can see they achieved payback within about 10 years. And 2 out of 5 of the dwellings didn't receive any economic benefit in terms of payback. They did not achieve payback within 30 years. So in terms of the social KPIs, this table shows that whether households achieved any benefit or didn't achieve any benefit in the indicators that were assessed. So in terms of the temperature improvements, again, 3 out of 5 dwellings achieved temperature improvements, and that was in terms of increased average household temperature and a reduction in the time that temperatures recorded in the household were below 18 degrees. One of the dwellings actually achieved a decrease in household average temperature as a result of the retrofit, post-retrofit, excuse me, and that was, we proposed that was attributed to a change in the occupancy profile of that household, and one of the dwellings didn't take back any comfort improvements in terms of temperature. The relative humidity results were different in terms of the fact that only one dwelling achieved any improvement in this way. In terms of the survey results, they were sort of inconsistent with the measured temperature and relative humidity results we got. So despite the fact that some temperature improvements weren't recorded in any of the households, 4 out of 5 households actually cited in their occupant surveys that they felt more comfortable post-retrofit. So in terms of the fuel poverty alleviations, we could only actually actively test 2 of the houses, namely C and D there from the table, because they were in fuel poverty pre-retrofit. But we did not see that there was any improvements in fuel poverty or any future alleviations in fuel poverty in any of the dwellings that we assessed. So in terms of householder satisfaction, there were various forms of satisfaction the householders cited in their surveys, mostly in terms of improvements in the quality of life as a result of the retrofit works, or even as simple as one householder said that he found that the benefit of the retrofit was that he had hot water on demand after the retrofit works were installed. So there was various reasons for householder satisfaction. But in terms of the dissatisfaction, the main dissatisfactions were in terms of the information that was given from the contractors and the engagement of the householders in terms of the retrofit design and in terms of the handover process, where householders felt that they were not given sufficient information for the operation of their technologies and for the maintenance of their technologies. And then finally, in the technologies that were implemented, some householders were dissatisfied with the new technologies. They found them too difficult to use. And some householders found that the PV panels that were installed in their house, they were not going to achieve any payback from them. So they were dissatisfied in that regard. So finally, in terms of the key findings of the environmental KPIs that were assessed, 3 out of 5 dwellings seen post-retrofit energy consumption and emission savings up to 60%, and 1 dwelling actually seen an increase, that's household E, in their energy consumption and emissions post-retrofit, and that was a result of increased electricity consumption. So some of the main conclusions were that economic, social and environmental benefits are achievable through retrofitting projects. However, various levels of retrofit benefits were achieved across the dwellings that were assessed, and that no 2 dwellings received the same level of benefit or combination of benefit. So some of the implications of this research, so from a policy perspective, demonstrating the wider benefits of retrofitting can serve to support the design of policy measures that maximise the benefits, and they can demonstrate the non-energy benefits of retrofitting to non-energy departments, can facilitate a convergent interest in energy efficiency. From an industry perspective, can support better design of retrofit solutions in the process. And in terms of contributing to literature, it adds to the studies that actually assess economic, social and environmental benefits of retrofitting. And by by way of measuring these the performance of retrofits in terms of the use of qualitative and quantitative data and case studies in their assessment. And from a householder perspective, the findings of this study can ultimately be used to incentivise householders to engage with retrofitting on a wider scale. So thank you for your attention, and I look forward to any questions at the end.
Thanks very much, Orla. Next up, we have Juan, who is joining us from Colombia today. So Juan, I think if you could share your screen with us.
Yes, on it.
Great, thanks. And I've seen we already have some questions on the Slido, so don't forget to also post questions for Orla on the Slido. Can you share your screen, Juan, or would you like?
Just give me a second, please.
Sure.
Okay.
Yeah,
You're looking at the screen now?
Yeah, thanks.
Okay, thanks. So, hello everyone. My name is Juan. I'm a researcher at EIA University in Medellin. Today I'm going to show you our initiative called Transactive Energy Colombia, and it's basically a research project with several lines which are all enabled by a peer-to-peer energy trading trial that we are currently running here in Medellin. So this initiative is a project alongside UCL, EPM, which is a local utility, one of the largest ones in Colombia, ERBE, which is a solar company that developed a peer-to-peer energy trading platform, and it's funded by the Royal Academy of Engineering and the Newton Fund. So I will present to you in a few slides, and as I say, the peer-to-peer energy trading pilot and some collaboration, knowledge exchange activities with UCL, and I'm going to talk about this in this presentation. So a little bit about the energy trading pilot in Medellin. So basically what we did was to interconnect through a digital platform 14 users in the Aburrá Valley, which is the metropolitan area of Medellin and 9 other cities in the valley. So basically what we did was to install some PV plants in residential users, in some households, mainly low-income households. I'm going to explain to you why. Also, we included 3 high-income prosumers that already had PV panels, 1 community house called Casa Colacho with the largest system, 4.5 kilowatts, and a battery, and 6 medium to high income consumers that couldn't otherwise access clean energy because they are currently living in apartments, so no access to roofs. So what we did was to deploy this virtual microgrid through the digital energy trading platform, through which prosumers could basically sell excess solar power to other users from the trial, mainly to those who, again, cannot access roofs or cannot install PV plants. A few pictures of the installation, and on the left side you can see the map of the metropolitan area of Medellin, and you see that users are spread across the valley. So this is how the app looks like. Basically what so prosumers can do, they can set their preferences in terms of to whom they can or with whom they can share this excess power. And basically, as consumers, they can also set the parameters of the energy supply that they want to consume. Basically, they say, I want to get energy from this person, or I want to get as much solar power as possible, and so on. And basically, the trader, which is the digital platform, matches the energy, the supply and demand of the participants. So far, since we deployed the platform, we have had a little bit more than 4,000 transactions, which is equivalent to 1.6 megawatt hours traded through the platform. And also we have seen the way people interact with each other. So basically through the app, they set again their preferences from which they want to get energy, or whether they would like to get as much as clean energy as possible. And as I told you at the beginning, we included some low-income households because of several factors. So in Colombia, as for solar business models as we have it right now, it's not possible for low-income households to access clean energy because basically the capex is too high in terms of the return of the project, and also because the demand is pretty low. So there are many factors. Demand, also the tariff is low. So most of low-income households have subsidized energy, which creates some sort of distortion of the market, and then the business model is not feasible for them. But through this trial, we want to explore whether the business model will be enabled because of basically pulling demand from other users through the platform. Sorry. So in terms of research from this pilot, we have 3 lines right now. I'm going to talk about the second one. So the first one is in terms of markets. So we are modeling and simulating peer-to-peer energy markets using the data collected from the pilot. And this is very important because in Colombia, we haven't had a study that basically characterizes the generation and demand profile of prosumers. So anything we simulate will be based on data from other countries. So we needed the trial for us to basically collect real data from real prosumers under the specific conditions of Colombia. The second research line is the value of these markets. So basically how we create business models and how do we generate value for prosumers and peer-to-peer energy trading users. And we're running a state choice study that I'm going to present you in the next slide. And the last one is policy and regulation. Basically, we are working on understanding how regulation enables peer-to-peer community self-consumption and transactive energy models in Colombia. So the value generation research line focusing on valuing these peer-to-peer energy attributes in Colombia through a state choice study from an end user perspective. So basically what we are aiming to is to identify the preferences and willingness to pay of residential energy users for the attributes of new energy supply enabled by peer-to-peer trading schemes. So basically we defined 4 attributes. You can take a look at this card below the box. This is how the experiment looks like actually. So basically we are asking for 4 different attributes. The first one relates to the supply. Basically we compared the current supply, which is the national grid, with solar power. The second attribute depends on the location of this supply. So we compared the country-wide generation, which is the national grid, with solar panels located in the region. We have a strong choice related to the region in Colombia, especially in Antioquia and Medellin, or solar panels located in the neighborhood. The third attribute is related to profit, basically. So profit goes to whom? Basically to energy companies, which would be business as usual, status quo, or we go to cooperative owners, or we go to a social cause, which relates to basically to the low-income households. And the third one, the fourth one is the ownership of the assets, basically of the generation and storage assets. And then we ask different scenarios depending under different tariffs. So under different increases. So the timeline that we set for this research starts with the attribute definition, which was quite complicated because, again, we're asking for hypothetical scenarios. Different to the UK, here in Colombia, you cannot switch suppliers. You cannot switch energy retailers if you are at residential users. So asking people to imagine how would it be basically to switch the supply in terms of their attributes is a little bit tricky. But so we took several months to define which attributes would be interesting for people, and then we ran several validations through focus groups, experts, a pilot survey which was sent a month ago to 333 clients, and then the final survey which was sent last Friday, and we got a little bit more than 1,000 responses out of almost 20,000 clients. And these clients all belong to the utility with which we're currently working. So the distribution was made through SMS. And all the clients
you have 1 minute left, okay?
Right, thanks. So the next stages, we have one relates to the power system itself. So we want to understand the impact of these DERs, or these solar resources, and these storage assets. We want to understand how they impact the grid, basically distribution grid. And we are deploying a new pilot starting next month, in which we're going to bring together from 25 to 30 participants under a different model. So the one that we are currently running is different DRs, different assets across the city. So under this new community solar pilot, we are going to bring together over 25 participants to co-own a virtual, it could be a virtual or a physical solar power plant. So we want to aggregate their assets, or we want to basically to set a collaboration model in which they co-own a larger solar power plant. Okay, thank you very much. And questions at the end.
Thank you very much, Juan. That was a very interesting insight into the Colombian peer-to-peer energy trading pilot. We'll now move to our last student presenter, who is Rami from Loughborough University.
Hello, yeah.
Hi.
Just a sec, let me share my screen.
Yeah, we can see it.
Good. Good. Okay. Yeah, hello everyone. So my name is Rami. I'm gonna present a little piece of research which I've been working on basically for since last winter. A mouthful of a headline there. But yeah, so implications of uncertainties in energy demand baselines on building flexibility. So yeah, I'm quickly going to start with a little bit of context around the idea of flexibility and what it means, what contracted flexibility means, and how I define it. What's the role of the energy demand baseline in flexibility? I'm going to present the experiments I've been doing in test homes here in Loughborough, and present the results and some conclusions and ideas where I will move on next. So yeah, flexibility, as kind of Bob implied there, the high level need comes from the increased share of renewables in the grid. So there is an increasing demand for flexible loads to be able to maintain, for example, frequency and maintain balance in the grid. This already kind of translates to monetary value through things called demand response schemes and balancing markets and so forth, where participants are paid for their participation, for example, by modifying their loads, or for flexible generators to modify their supply in response to imbalances in demand and supply in the markets or in the physical grid. so deliver flexibility in a specified form by aggregation of multiple buildings for balancing services. And that's kind of the context in my research. I want to explore how buildings could be become active parts in aggregations in these balancing and demand response markets that are emerging. Here's the basic kind of plot of what a building or an aggregation of buildings should be delivering when it participates in demand response. So in bare bones, there's a so-called notice period during which the resource, i.e. a building, has time to prepare for an upcoming demand reduction phase, which is here then marked by a red zone, which is then when the demand has to be adjusted according to, for example, over a specific period of time and for a specific volume or power over that period of time. Important to kind of, and this is kind of how I got over my first year of PhD, is that when you're thinking about a building, you need to understand that the demand reduction or the request has to be based on some form of a baseline, so a baseline load, which kind of represents a business as usual scenario against which is then the demand adjustment is made. And that's the that difference is key to then actually quantifying the flexibility contribution made by a building. And hence I wanted to explore these baselines and understand how these baselines affect how we perceive or conceive flexibility, and how then that might affect, for example, distributing incentives and so forth to participants in a demand response schemes. So how do different uncertaintties in measurement, modeling, and forecasting affect the baselines that we use into context flexibility and in when a building participates in demand response? So what I did was I constructed different baseline demand scenarios. So what would building contributions be compared to an industry standard baseline, which represents baseline methodologies that are used these days in demand response schemes. Then I observed what would a forecasted baseline look like if you would use a baseline which you developed by using building modeling prior to the demand response event. So kind of like your estimate in the future, what would be a business as usual scenario. Then I took a modeled baseline after the event. So basically I used after the event data to create baselines which would represent the business as usual scenario if you would have the information after demand response events. And then finally, I used an actual measured building as a baseline. So a building which didn't have anything, didn't have flexibility imposed on it. So it was not delivering demand response. I measured the energy demand, which then acted as a measured baseline. So I did, this was achieved by match pair experiments in Loughborough test homes. I installed different measurement equipment and put together the necessary control and measurement equipment in these homes. I also installed a cool weather mask, which I'm very excited about overall. Anyways, and then what was running in the buildings was a model predictive control strategy, which I put together. It basically was set to deliver as much flexibility over the demand response hours. And the model predictive control was basically solving constantly an optimization problem, which had flexibility events incorporated in it. While still maintaining an acceptable level of comfort. So here's a time series data over this is 4 days. So basically there's always 4 days, 2 days of events in one building and then 2 days of events in the other building. In general, the model predictive controller responded by preheating the building before the demand response period, and then reduced the indoor temperature to cope with that, basically trying to produce a demand reduction over these periods of time. You can see that by observing the indoor temperatures in those green and red areas in the plot. The data, then I did this repeatedly, been doing this repeatedly until last month, basically in the homes over the last winter and spring. So here's then the kind of where it boils down to in terms of then actually quantifying the different uncertainties. So I looked at all the different uncertainties and errors introduced in operation. I then took the baselines and compared each of the baselines to the realized demands and quantified the uncertainties by using a test data set over around a month. So all in all, the industry standard baseline resulted in quite high uncertainties due to it being basically industry standard baseline, which is so-called high 5 of 10, is only defined on a day level. So it doesn't incorporate the actual dynamic nature of a heat demand in a residential building, which you would actually see, hence the high uncertainties. Then there's the projection, so your forecasted uncertainty. So I basically compared the forecast to the realized demand, and as you can see, the uncertainty was reduced. But then using more information, adding more information, and going down to the measured uncertainty, the uncertainty can be reduced to actually quantify even smaller demand reductions. All in all, what I kind of validated was that high uncertainty actually does reduce ability to verify smaller contributions. So what I'm planning to do next is observe more and analyze more the uncertainties in these baseline energy demand predictions and trying to kind of hone down what causes these uncertainties and what are the major role and kind of find and show that they have a major role in verifying individual building contributions. I'm also planning to look into how the uncertainty behaves over, for example, aggregations of buildings and how they behave over time. Thanks, everyone. Here's a couple of pieces of literature if anyone's interested to follow up on.
Thank you very much, Rami, for your presentation. We're a bit over time because of like the technical issues at the beginning, but we will take some time now for the Q&A session. Before we start that, just a reminder again to vote for the best presentation because you've now heard all 5 of them. The details will come up on the screen in a second. I'll share it now, but I will now hand over to Ahmed and Charlotte for the Q&A for the student presentations. So all presenters, be ready to unmute yourself and answer the questions. And don't forget to keep on posting questions if you can think of more.
Okay, so there were some really interesting presentations and thank you for all of those. So I guess we'll go from the ones which came in first, which obviously, so one had a question from Dan. He says, have you noticed any predictors of who requests what type of energy and from what source? Does price seem to be a leading motivator?
Okay, that's for me. Yeah, so we would expect people to behave rationally in terms of price, but this is a very long shot. I mean, it's very early for us to actually tell what would be the main driver for people. I mean, from the pilot survey and from the validation stage, we conducted focus groups and interviews, qualitative research with the participants of the pilot, and there was a strong tendency to choose locally generated energy and also clean energy. So profit was not really a driver from the qualitative research, but again, it's too early for us to tell.
Okay, I realised
Great.
that.
Okay, great.
Backwards bit anyway. Sorry.
Do you want to go on for Charlotte? Do you want to go?
Okay. So sticking with one, Helen Thika asks, have you published this research yet?
We have only published research related to regulation so far. We expect to publish our research on value, on the choice experiment in a few months.
Okay, thanks. Anna, do you want to do the next one?
Yeah. The next question is from Rob Johnston. I think it's for Nicole. And he is asking, he's saying, does the fear that changing or investigating to a cheaper supplier would reveal past financial losses fit into the behavioral economics model?
Yeah, thanks for the question, Rob. So in my understanding of it, the idea of loss aversion is more related to future losses rather than past losses. But I think it's an interesting question. I've not heard of this idea of fear of future losses within the behavioral economic model. Thanks.
Great. Thank you very much for the brief answer. The next question, I think, is for Ola. It's from Dan. The question is, can you tell us more about the dwellings that made up your sample? Were these typical of Western Ireland? I noticed some bungalows.
Oh, thanks, Dan, for your question. So I can give you some more information on the dwellings. So they were rural detached dwellings in the west of Ireland. They were single family dwellings, and they were constructed between the years of 1920 to 1980. So within that range was the construction years. So in terms of if they're representative of the Irish housing stock, so over 80% of the Irish housing stock consists of single family dwellings. 42% are detached dwellings, like the ones I use in my study, and 83% of them are rurally located, so quite representative in that sense. And in terms of the construction year of the houses, so they were all pre-1980, and over 50% of Irish dwellings were built prior to 1979 and prior to the introduction of the earliest building regulations. So they're representative of a significant portion of the Irish housing stock. I can give you more information on the retrofits or anything like that were installed in them. If you would like more information on that, you can just contact me to give more or ask another question. But I just don't want to monopolize too much of the time by going on to it, if that's okay. Thanks.
Thanks, Ola. So another question that we had for all of you in light of the current pandemic situation is, what challenges, obviously there'll be huge challenges for you with COVID, but what challenges specifically do you think you're going to face, and how are you going to overcome them in the next coming months with your research? Shall we start with one, because you answered first?
Okay. It was very challenging for us because we were expecting to launch the survey, the final survey, in April. And basically at the beginning we were discussing whether we should move forward with the survey during this time. Right now in Colombia we are under lockdown since the 23rd of March. So well, at some point we decided that we couldn't just extend the launch of the survey forever. I mean, the project has to go on, so we had to formulate new hypotheses in terms of the impact of the COVID-19 on the way people would answer. So one of the questions we had in the survey was to assess how people where people usually engage in social activities like collaborating with the community or engaging in other kind of activities such as donations. And of course, during this time, most of the people or several people in Colombia have donated, have contributed money or food to the poorest areas in the country. So we would expect it to affect the way people answer, but also we were wondering whether this would be the new normal, right? So ideally, we should run another survey in a different time, maybe in a year or in 2 years, once we have got back to normality, whether that makes sense, whether we actually go back to normality. So that was the main issue for us. But at the end, we decided, again, during in April and May, with all the interviews and the focus groups we ran, we decided to go ahead and launch the final survey. We need to be very careful with the way we assess data, and hopefully we should do some sort of control by the end of the year or in a year.
Thank you very much, Juan. That's great. I think the COVID issue is a very relevant and current issue. It also actually came, I think, in your presentation, Rami. So could you just tell us a little bit more about how it affected your research?
Yeah.
Rami?
Sorry, I was just on mute. Yeah, well, I did experimental work. So uni closed, and it has impacted my work. In also in quite concrete real terms of not being able to do certain experiments which I wanted to do. However, I was lucky to have my test setup done, so I was able to perform remotely experiments in test homes. But yeah, the future is murky for experimental research overall, involving or not involving people. So yeah, I guess let's see how it will turn out.
Great, thank you very much. Thanks again to our presenters. Thanks to the listeners. I'm going to hand it to Anna to welcome our keynote speaker.
Right, thank you very much for that, Ahmed.
Sorry, could I just say as well, we'll there were some more questions and we'll stick around afterwards to answer those. But yeah, carry on, Anna. Yeah,
just a brief reminder again, don't forget to vote and keep on asking questions, and also go on Twitter and tweet about us. So now I'd like to welcome Professor Mark Gillett, who is a professor for sustainable building design at University of Nottingham. He has over 24 years of experience in low carbon sustainable energy technologies and sustainable building design. And he will now talk to us about his current project on how to energize communities. But I'll stop here and let Mark continue his presentation. So Mark, if you would like to share your screen, I should stop sharing mine now. And we will have the Q&A session at the end of his presentation.
Check everyone's seeing that.
Yeah, we can see it. Thank
you. Good afternoon, everybody. So firstly, thank you to the organisers for inviting me along to talk today. And hopefully I can make it interesting for the next 30 minutes or so with a project we're doing here in Nottingham. And it's not just me, it's a substantial team of people working on this big project here in Nottingham with a significant amount of industrial support. So I think the first slide there says quite a lot about the project. It's one of the original CGIs, the architect's impression of what this development might look like, and that'll make sense when you see where we started from the original land that was reclaimed to build on for this development. The work we've done to date has been largely funded from Innovate UK, the Energy Research Accelerator, and more recently through the Active Building Centre. So the presentation I'm giving you this afternoon is entitled Energising Communities. It started off as an industrial academic collaboration through an Innovate UK project called SEAM, Sustainable Community Energy Networks. And largely what I'm going to talk about is tried and tested technologies, but creating new business models and new ways of implementing community energy within the new builds.
Please all make sure you're muted. Sorry, Mark.
Keep the background. So you can see some of our collaborators there. So two universities ourselves at the University of Loughborough. A.T. Carney led the project as a consultant, but one of our key partners really, Blueprint Igloo Regeneration. So it's their site. Without their participation as a housing developer, we wouldn't have been able to do this. And then other companies coming in to deliver some of the technology that's been used in the project itself. When we went for funding, some of the key messages that the consortium put out there was to create a subsidy-free commercial model for new build residential developments, to enable developers to deliver renewable energy systems in a different way. The investment not coming from themselves, but coming from a energy services company, another provider running in tandem, in parallel with the development, so that once the developer left the site, the energy services remained there, and there was an entity to look after that. So that's some of the rationale behind the project, removing the risk from the developer. And the key thing that we've been looking at is the new business model development of how this would work. Essentially, it's creating I don't want to say a smart grid, it's a heavily overused term, but a smarter system at the low voltage network level. So moving everything onto the electrical network at a community level. So that's heating, eventually transport with EV, and then being able to manage that through embedded generation and storage on site. So our storage medium is in power, so we have a large community energy battery, and then our next stage of the project will involve a large community thermal store. So we have the ability to trade, to arbitrage between our electricity vectors and our thermal vectors at a substation level. It also gives us the ability to provide grid services from the local energy system. So these are revenue streams that the ESCO then can use to pay back on the investment, but also provide a share surplus to the community, to the residents living in the homes on site there. And then all of this is controlled through a cloud-based data management system. And of course, with all the data that we're collecting, we've also looked at other ways of generating additional value from other types of aspects, such as assisted living, healthcare, and security. For those not familiar with Nottingham as a city, so the city itself, circa 350,000 people, and probably double that in the greater Nottingham area. The image you can see now with the blue, yellow and purple lines are redevelopment areas that have been earmarked within the city. And the area that we're focusing on in terms of the Trent Basin scheme is in this red area here. So where the cursor is there is the Trent Basin itself. So that inland dock is, in terms of its physical size, it's around about an acre in size. So all of these areas is earmarked for redevelopment. And just to put that into context, that's Nottingham Forest Football Ground. Just down here, we've got Trent Bridge Cricket Ground in Notts County, one of the oldest football clubs, the oldest professional football club in the world. And then the city centre up here, and then over to the west at the university. Originally the site, so at the moment it's largely still light industrial, so it's a brownfield redevelopment area, and it's land that's been earmarked by the city for housing and new education facilities and mixed-use facilities. But originally the site was set up as an inland dock on the Trent to link the industries of Nottingham with the greater world. So this piece here, you can see, sort of shows you some of those warehousing facilities that were originally on the site there. Nottingham's highway to the sea, the Trent Lane depot. And that facility significantly increased Nottingham's capacity to deliver export and import goods substantially. Bird's eye view of the site. So here you can get a better view of what we're talking about when we say Trent Basin. It's this inland dock here, and again the city centre up here on this bird's eye image. The scheme itself is being developed by Igloo Regeneration. So Blueprint are a joint venture within Igloo, a joint venture partly owned by the City Council, and it's being developed in a number of phases. So phase 1, 2, 3 and 4. We're currently on site, so it's a live project. It's evolving all the time. Phase 1 is now fully built and lived in. Phase 2 is complete and partially lived in. There's a number still up for sale. And phase 3 is on site at the moment. Some images of the site itself. So it's taken from the other side of the river there. So apartment complex, and then it's largely townhousing across the main site. Originally, when we started off designing and developing solutions for this, it was going to be a lot of apartment complexes, but the market changed. The developer realised they weren't selling. We had to adapt and move to these townhouse provision that's on site now. And so from that CGI to reality, so the apartment block in the background there. So early photos taken before much of the landscaping's taken hold. And then the CGI of phase 2. So the river fronted properties, the largest property, single property on site, the tower house on the corner there. And there you can see the basin itself, and then beyond that the city of Nottingham. And then one of the more recent images that appeared in the local news recently just concerns that much of the construction in this area has stopped due to the recent COVID events, and reassuring to see in the local press that everything's going to be back on track with significant investment coming back into the site here. So you can see another artist's impression of what the site might look like in a few years' time, with the proposed school in the background now. I'll come on to that later in the presentation. So working with the developer and partners, the industry partners, we used the ERA funding, the Energy Research Accelerator funding, to put significant on-site generation in place, and a community energy battery, a community energy hub, so a hub within the development that the residents could use as a social space, but also engage with the project, and I'll come back to that shortly. So the idea being that photovoltaics are put across the most appropriate roofs on site, but they're not owned by the homeowners. They're part of the ESCO's assets, and we had to set up new legal terms and conditions to enable that to happen. At one point, it was looking like we were potentially going to be unsuccessful because the Council for Mortgage Lenders were looking at putting a stop to sales because of the way that the agreements were put in place. So we had to set up new legal terms to enable this to happen, to allow the ESCO to own an asset on the private homes that are on site there. Before getting on site, the developer put in a private wire, so linking all of the homes and areas we might put photovoltaics back to the energy centre. Our private wire on site is a generation side only. All of the homes have conventional connections to their own utility supplier, so they are free to choose whoever they like to supply their energy. So the community energy battery was located on land that we had to purchase and get rights to put what at the time when we put it on was the largest community energy battery in Europe. So new technology, substantial planning issues, Environment Agency issues to address to put a battery of that size within the middle of this housing development. One thing that became apparent was there was plenty of land waste industrial land on site very early on that we had access to generate energy before any of the homes were going to be built out. So we explored the idea of putting an urban solar farm in place because we had the photovoltaic investment already. We had that capital investment of the PV. So we have a on site now, and it will run to September, October this year because the school will start on site at that time. We have a 200 kilowatt peak solar farm. It's been connected and strung up in a way that it can be decommissioned to match the phased building of the homes. So the PV on site will go directly onto the housing. This is the battery going into on site, so 2.1 megawatt hours energy storage with a 500 kilowatt connection. And there you can see at the top left image, so it's a Tesla technology. In our energy center, our electrical energy center, we have our own low voltage distribution panel. So we're connected onto the high voltage network, so we go through our own substation. And then because the battery is in the middle of a residential area, we have a security and acoustic fencing surrounding that to prevent any noise pollution from the battery to the surrounding homes. This was that wasteland I was talking about. So some photos taken during the construction of the solar farm there. It's about 200 kilowatt peak of solar there on, and they're on roof mounted systems, so that all the mountings, the inverters, the cabling, the PV is not wasted. It's reused on the homes and the school as we build out the development. Within the community hub, one of the central focus points is a large touchscreen display that gives visitors to the centre the ability to interact with different aspects of what we're doing. So we work very closely with IES to develop a virtual twin for the site. So one of the first virtual twin projects they did, and here you can see the phase 1 developments, the apartment block and the houses there. And effectively that touchscreen allows you to touch onto a home and bring up the live data or the historical data from that home to see how it's performing. The researchers have access to that. For the general public, we have anonymized data sets. So we have an average data set for homes in terms of complying with our GDPR compliance on data. So that's one of our interfaces with how things are operating and working. We work closely with one of our industrial supply partners, Core Controls, to develop a SCADA system, so a supervisory control and data acquisition platform that enables us to collect data from all the different assets across the site, but also enables us to control those assets as well. So when we come to multi-vector optimization, switching things on and off to optimize things at a local level, we're able to do that. And it's also been future-proofed to bring on additional assets in the future as we start to bring heat into the mix with our heat pump systems and our local area low temperature district heat network that's being proposed for later on this year, along with EV communal charging. Just some typical data sets that come out of what we're collecting here. So hourly PV generation, January 2019. These are slides I've used in, we were having regular meetings with the community to discuss how things were progressing and recruit them into the project. It's been very important to engage with the community with what we're doing as the heart of the project itself. So here you can see in January, averaging enough for around about 14 homes. Other ways of communicating with the homeowners, with it being online, we've got in-home displays accessing our web portals, tablets and smartphones. And we were very early on, we started to engage with Alexa, Amazon Alexa, and we provided the homes with a smart speaker. So we wrote our own skills, so Alexa skills, to enable homeowners to ask Alexa how much energy they were using, average across the site for homes of their own type, what the battery's doing. So all the data we're collecting, it can be interfaced with something that we see as probably something they're going to use on a regular basis, whether it's just to listen to the radio or to control different aspects of their home. But more and more we're seeing smart speaker usage, and we saw this as an opportunity to try and embed our own monitoring within that platform. It also enables them to control their heating systems, because we've used a Honeywell system that we have access to the control, the back end of that to get the data from, but it allows the homeowners to control the heating with that. We set up our own community energy data platform at a time when GDPR came in with the university, so we were the test case for a project collecting large amounts of personal data. And so I think we were the first project to get full GDPR compliance with what we were collecting there. So we put that data acquisition platform together ourselves. I just put these in each of the homes. We've got very low cost hubs, local hubs to communicate with our data acquisition devices around the home, whether that's for collecting energy data or environmental data, and then that goes up to the cloud through the homeowner's own broadband connection. So past experience has told us that if you use the homeowner's broadband connection, it's likely to stay on more than if it's something separate. So again, trying to keep everything maintenance free and trouble free as we possibly can, and that's why we stuck to the vast majority of our sensors using N-Ocean energy harvesting wireless sensors, so we didn't have battery swap out issues with the sensor technology. Data sets are then cleaned and presented through the different portals that have been produced throughout the project. So at a community level, we're collecting site weather data. So on site there, solar irradiance, we've got global, and we've also been fortunate enough to get a split down to direct and diffuse radiation on site as well. Temperature, humidity, wind speed, direction, and rainfall at a very local level. Within the community, we're monitoring what's happening on the grid, the generation, in the future, what happens with our heat pumps, our thermal store, and then in the home and on the different panels, what's being generated. In the houses, we've got a number of temperature sensors, humidity, carbon dioxide, a passive infrared sensor, and then on the electrical circuits, we're measuring some of the key appliances and circuits, as well as total electricity, heat metering on hot water and space heating. This all goes to the local hub, then off to the energy centre, to the cloud centre. I put these in the presentation, so these were part of the handouts that we gave to the homeowners, explaining what they got in their house and what we were doing and why we were collecting that data. So smart thermostats, we were quite fortunate in that Honeywell have given us access to the API, so we can get full access to that data to enable us to provide remote control of the heating system if needed, and we've got full data acquisition in terms of when and how the radiators and the heat emitters in the homes have been used. Heat metering and energy meters, so each circuit has its own energy meter on it, collecting data. And then in terms of what the homeowner sees, it's pretty inconspicuous. This additional box underneath the utility supply, underneath the consumer unit, houses the Raspberry Pi with all the hardware needed to transmit back to our cloud-based servers. Example of house, so I'm sure people are familiar with these. Again, this is just data I've used to show the homeowners what the data is providing us. So typical electrical energy consumption for a home where people were going out to work. That's changed over the previous months, as we can now see. So early morning rising, and then a lot of electrical energy use during the evenings, mornings, very little in the day. Aggregated, so this is 21 homes, I think it was at the time, over a 24-hour period. So you can see here again, when you start to aggregate it up over the entire development, we've got this typical trend of electrical power consumption in the morning, dropping off slightly during the day, and then large usage at night. And then the interesting thing for all of us to get to grips with is this element here. So what's happening between 12:30 in the night to 3 a.m., this 7 kilowatt peak, which is a significant signature across 21 homes. This is in fact just one electric vehicle being charged at one of the houses. And then when you look at the houses in that sample, break it down to lighting, sockets, cooking, that single EV is the standout electrical item within the disaggregated data of those 21 homes. So again, something to bear in mind when we're looking at how EV electric vehicles are going to come into the low voltage network of the future. Peaks and lows. So this again is that sample just to get an idea of the average across the homes in terms of their electrical consumption. So up until that particular point, we were seeing averages of 7.7 kilowatt hours for every 24 hours for those homes. PV generation not matching the typical. So most of the people living there are professionals who go out to work during the day. So this is a pretty standard electrical profile for a home there. And of course the PV generation being generated at a point where it's not being used in the home. So again, showing partly substantiating the reasons for moving towards why we're going for a community system that we've got in place there. Temperature monitoring, so highs, lows, and average values there, sampling, humidities, so relatively good in terms of how the homes are performing. And then every month we've created a energy audit report to give to the participants so they get a feel for how the system as a whole is working, so how the battery's performing, how the total PV on site is performing, the carbon reduction savings associated with it. So here you can see in September, 142% of homes in 2019, so PV generated electricity supply, 142% of homes. So remember at that particular time that the site's still not fully developed and lived in. And then they can rank themselves against a similar property. So that's the other thing we're doing is there are a number of identical property types in terms of the layout and design of the homes, so they can get a feel for how they're performing against the property type of their own type. Key thing was this privacy issue. So not only did we have to work extensively with the legal teams around some of the new business models that we're proposing around roof lease, so there's an access rights to the equipment going on sites, but also GDPR compliance with the homeowner agreements that we put in place. Moving forward, some of the work we're doing now with the Active Building Centre. So our partner Smart Club that we've partnered with to set up Trent Basin ESCO Limited. So that's the entity that runs the community energy service. So on site there, we have an off-gem derogation that was granted. So the ability to do something different outside of the current regulation and legislation on a trial basis at site there, on site at Trent Basin. So we're going to do joint billing. So the ability to provide a single bill that combines the utility of the home and the behind the meter supply from the local generated electricity. So we're setting up a number of different case studies once we can get back onto site. So control group, so no energy supplied by the ESCO, own utility bill. So there's separation between the local area private grid that we have, the energy centre and the national grid. Case 2, we'll be putting some PV onto the roofs of homes, and then the ESCO will be supplying that PV generated energy to the homeowners, but there's still no connection to our own energy centre. In case 3, we then connect back to the energy centre, so our PV can generate directly to the energy centre. So the homeowner has the ability to get revenues from that PV. And then case 4, we can then supply back behind the meter, both in the future homes that are going on site shortly and the school on site. So the ability to supply that local generated electricity back behind the meter to those homes. And that brings me to one of my last slides. So in terms of where we go at the moment, so there's 74 homes on site at the moment, lived in. Later this year, we're just working at the moment with the Active Building Centre and the Department for Education to look at how we can create a new energy hub, part of the Waterside Primary School. That's due to go on site later this year. So a 420 pupil primary school, running off a heat network linked to a number of the houses, and also linked back to our electrical energy store to enable us to arbitrage, to trade between the grid, the electrical energy store and the thermal energy store to optimize the system as a whole on site at Trent Basin. Finally, I think it was Bob Lowe that mentioned at the start, it's been a rapid change over the last number of years in terms of decarbonising the electrical grid. But you know, these aren't new aspirations. We only have to go back over 100 years to H.G. Wells and anticipations, talking about building things differently, and Thomas Edison back in 1916, with a bit of a nod to renewable energy and what we're doing wrong, and hopefully going forward, you know, the challenge is there now. Move forward to a new way of doing things. More information on the project as a whole can be found at the projectscene.uk website. Okay, thank you. That's my presentation. I think I'm now due for questions.
Thank you very much, Mark. Yes, indeed. Now the Q&A for you will start. We've collected some questions on Slido, so Ahmed and Charlotte will now present them, read them out. And Ahmed or Charlotte, feel free to ask people to unmute themselves if they want to explain their question in more detail.
Okay, so first question is from Ali, who wants to know, Mark, if you have considered the real-time measurement load and real-time reaction of the demand side management impacts.
Not at present. So I've got electrical engineering colleagues that are very keen on investigating all of those aspects. So we have the ability to do that. So we have the measurement facilities in place in our energy centre. That our key thing at the moment is just been getting the infrastructure up and ready to implement some of the later projects. So this is very much a project that's ongoing. And the key thing at the moment was to make sure everything was in place to enable us to get good, reliable data moving forwards. But you know, you do create an awful lot of data as well. You know, I have electrical engineering colleagues that are obsessed with millisecond data, and that generates an awful amount of data, awful lot of data. Yeah, but it's still early days for us.
Thank you very much for that answer. The next question is from Anonymous, so I can't see the name of the person who posted this question. But the question says, do you think this model can be replicated anywhere within the UK?
Very good question. So the honest answer is work in progress. Things change all the time. Just to give you an idea, when we started on the project, we had grid service contracts in excess, so it was around about £130,000 a year just on an FFR contract for what we were proposing. We missed the deadline in install dates, and that contract went down to a third of that value. So things need to be flexible. We need to have the ability to change over time as the grid changes, as the value streams change. We can't be reliant on one particular value stream. So that's been a big lesson. Our industrial partners, so Smart Club, they're ex-utility guys, been in the profession for most of their careers, and you know, they've worked with the Big Six for many years, and they wouldn't be doing this if they didn't see that there's some value and future for what's being proposed here. I'm not sure if that answers it. We've also spoken to a number of developers that over the last 6 months who are now taking some of what we've done and trying to apply it to their own schemes.
thank you very much. That makes sense. That was just perfect. I'm just gonna say some people may have found using Slido challenging, I think, or they may want to come back with some sort of interaction discussion with the keynote speaker. So if I am going to allow you to come to the mic if you want to speak, so please raise your hand. But in the meantime, we will just go through the questions that we have for him right now. The next question is from Nicole. So the question says, what is the governance of this community project? Who's taking decisions? What can local homeowners say or decide?
So at the moment, the main governance is Trent Basin ESCO Limited, so a company that was set up specifically to manage and control the assets on site there. We've had continuous dialogue with the homeowners and residents on site there. So we have regular homeowner and residents meetings, and they will be, so just before the lockdown, we were about to launch the joining up of the ESCO. So the homeowners can become members of the ESCO and feed directly into the decision-making process. And the business model that's been set up eventually will allow the ESCO to provide share ownership to those homeowners as well. So it's very much a process of engagement and consultation. And that's being done at the moment through an app that's been developed to keep the back end costs down, to enable people to communicate remotely through an app-based communication platform. So on that app-based communication platform, for instance, going forward, there might be the ability for the homeowners, for the ESCO members to vote on different proposals in terms of how the ESCO will invest money. Yeah, very early on, we asked that we had meetings with the homeowners about how they would like the money raised, the revenues raised to be used. And the outcome of that was a surprise to all of us. The motivation wasn't really financial. I think that's probably due to the demographic on site there, but financial wasn't the main driving concern. Environmental was clearly the main driving concern for most people living there. And in terms of financial payback, and they'd rather it was at that particular time 50-50, so 50% to the homeowners and then 50 to a community fund to invest in further community assets to create a better community and a better place for where they're living. I hope that answers Nicole's question.
Okay,
yep.
Thanks, Mark. But Hugo wants to know what kind of measures you've taken to deal with the overheating risk for each of the occupied spaces in the homes, and whether you conducted any building performance evaluations to predict any discrepancies between the actual and predicted energy use, which I think is quite an interesting question.
Yeah, so we've been in a slightly unfortunate position in that, fortunate that we've got a very proactive and engaged developer that we're working with. Phase 1 homes that are lived in now had already been designed, so they'd been through all that planning process before we got the project funded. So much of what we've done has been retrospective and been retrofitted in. That's not the case going forward. One of my colleagues and her students did thermal simulation of the homes. I'm conscious that this is being recorded and potentially would be looked at by a number of people. The answer to that is from a shading perspective, they could be I mean, people here are educated and can see the issues there. Lots of glazing, south face, southwest glazing. There are overheating issues. So that's something we're recording. But yeah, the question is, were they optimized from an environmental design perspective? They're much better than building regulations in terms the thermal performance, but in terms of some of the aspects that we would be looking at, there's more that can be done. I hope that kind of intimates what I'm suggesting. Now, have we done some post occupancy evaluation of the thermal performance? It's not the remit of this project. Other projects in other groups have done some work. We've had projects with Saint-Gobain where Saint-Gobain have gone in and done their co-heat test and their rapid temperature decay test in there to get some heat loss coefficients on site there. And that data at the moment is being reviewed for publication.
Okay, great. One extra question from Dan Wright. What are your plans for the Honeywell Evo Home heating control data? What do you plan to do with that data?
So at the moment we're working on, so through the work we're doing with the Active Building Centre is setting up the ability for the research community to go in and get access to that data. So we're looking at ways of enabling others to access the data for their own research. So that might be of interest to this group listening. We're not there yet in terms of GDPR compliance, and some of the initial work we did with GDPR, but we hope to in the very near future to enable others to access that data to do analysis of that. So we've not really dug into the Evo Home data at the moment in terms of how people are controlling the heating within their homes. We bear in mind we've only had one heating season anyway since that went into the houses. Yeah, I think that hopefully that answers that question.
Thank you very much for all your questions. I'm gonna close the Q&A officially here now, and might have a bit of another Q&A session after the closure, basically, of the conference. But mindful of time, I think we just need to go to the winner announcement and the closing remarks. But we have your questions, and we will ask them later. So yeah, once again, thanks everyone for joining us today. Before we close, Nikki has the winner with her, so I'm going to now hand over to her to reveal the results of the voting.
Great, thanks Anna. So like Anna said before the conference draws to a close, we have our announcement for the best presentation. Thanks everyone for voting. It was a very close call, but unfortunately there can only be one winner, and the winner today is Nicole. So congratulations to you, Nicole, for your presentation on consumer engagement with local energy. And well done to everyone else for your very interesting presentations as well. I'd like everyone to unmute yourselves for a moment and join me in giving them a round of applause. But before we do that, I'd like to also thank our keynote speaker, Professor Mark Gillett, and Professor Bob Lowe for giving the opening address. And of course, thanks to everyone that supported the organisation of the conference, and also to everyone for attending. So at this point, if you could kindly unmute yourself and join me in giving them a big round of applause. I'll give everyone some time. Great.
I would also like to congratulate and thank you, the organizers, for the great lineup and all the work you did to organize such a success. Thank you all.
Okay, thanks Virginia. Thank you for that. And one last thing that I'd like to do is if we could, if you would want to be in a group photo, if you could turn on your webcams right now, and I'll take a quick print screen just to have some photo evidence of the conference. Okay. Great, thanks everyone. A few more people to go.
Should I stop sharing my screen? Will that make it easier for you?
You can do if you want to. Okay. I think it's fine.
Like this.
Great, thank you.
No one in their pajamas, that's good.
Okay, I think that's perfect. Great, thanks everyone. So we said that if there were a lot of questions coming through, we'd carry on the discussion at the end of the conference. for anyone who wanted to stay and join in. And we do have some questions. But before I hand you back to Charlotte and Ahmed, I'd just like to say thanks again to everyone for attending, and thanks to all your patience with the technical difficulties. The online conference format has been a new one to us and probably to you guys as well. So we really appreciate everyone's patience today. I think all in all, it's gone quite smoothly and it's been a great turnout. About 100 of you have joined us. So that's quite exciting. And hopefully we'll see just as many of you next year when this will be held in Loughborough and hopefully in person. So thanks again to everyone. And I'll hand you back to Charlotte and Ahmed at this time.
Thanks, Nikki, and thank you for everybody else as well for taking part and for joining us. If you've still got any questions, or if you're thinking of more questions, do put them up on Slido, and we'll get through them. Otherwise, I think actually most of them were for Rami anyway, because we didn't get a chance to ask him.
And we have a few more questions for Mark as well.
And a few more for Mark as well. Ahmed, do you want to ask the questions for Mark while they're still fresh in our, well, it's still fresh in our mind?
Okay, yeah, I think this question is from Bertugo. He says, the question is, have you already conducted post-occupancy survey just after installation of PV panels at the residential estate?
No, let me just check on. Yeah, I'm unmuted. So no, we haven't. So the PV panels for the phase 2 homes, literally they went on the homes, the last panels, just as the lockdown happened. So we're in a bit of limbo like others with our research at the moment. Yeah, no, it'd be interesting to find out how the occupants have taken to that, because it's an unusual situation. They have PV on their roofs that they don't own, and they don't directly benefit from it. So all of that generation goes back to the energy centre, and unless they join up and become members of the ESCO, they don't get the revenues from the ESCO either. So it's uncharted territory. And so yeah, we're looking forward to finding out how that's gone. I think there was one from Dan Wright as well, was the energy reports.
Yeah. Yep.
So again, Dan, so the energy reports, we finalised those energy reports for every month for every house just before the lockdown, and we don't want to put those out without having the proper interaction with the homeowners to go through what they mean and how they can interpret the data. There's an awful lot there, because for some of them there's over a year's worth of energy data and home information. So again, it's something we're looking forward to have that opportunity to do moving forward. But it's really important that we have them fully understand what they're reading, to be able to put it into context. And we can't do it electronically, so we were discussing whether we could do this over the network, using Teams or Zoom. And there are a number of homeowners that don't even have they're not literate in terms of IT literacy. So we don't want to put disadvantage some of the people within that community. Face-to-face meetings tend to be our way forward, but we may have to change that.
Okay, that's great. I think this question also is related to what you have been just talking about. You may have addressed it, but I'm just gonna say, do you feel like demand behaviors may have been influenced by the reports?
Yeah, well, that goes back to, so we haven't given the reports out yet. What I said before, we've just created the reports, so they're ready to go, but we want to talk through what the report actually means. We certainly hope they will. Some of the interactions that we've observed with Amazon Alexa, so the Alexa skills we set up, we've also put some nudge behavior prompts in the Alexa device. So if their house is too warm, or if they're using more energy one day compared to another, just letting them know that and understand why that's the case.
Okay, that's great. That's great. I don't see any hands up. If people want to speak and ask something themselves, we'll welcome that. But I don't know whether that option is available or not. Nikki and Anna, can you see any hands?
I can't see any hands, but just feel free to unmute yourself and ask the questions if you have
go
one.
on. Yeah.
There is another one actually for Mark about the connections that the homes have and whether they've got do they have a public distribution grid connection and a microgrid connection within the project, or sort of how does that work?
So all the homes have their own utility connection. So there's no supply side connection to our energy centre at the moment. In future phases, we will have dual supply, so behind the meter supply from local generation, and that's because we have this off-gem derogation that enables us to do that with the joint billing from the multiple suppliers that we'll have on site there. But at the moment, it was partly the developer insisted on it right from the start, saw it potentially as an off-putting thing if they were locked into a private wire and a sole supplier agreement. So wanted the ability for the buyers to have a choice, and they have that. They can sign up to whichever utility they want. But in the future, we have this ability to supply local generation behind the meter and create a joint bill to reduce the complication of multiple bills.
Do we have any more questions, Charlotte or Ahmed, or?
There's just one for Rami, sorry, that I can see.
Well,
is Rami still with us in the conference? He might have left already.
If I can see.
Oh, there he is. Yeah.
Yeah, I think all the presenters are here.
So I don't actually know who this question is from, but it says, while assessing the uncertainties of baselines, did you use a confidence interval to determine the reliability of the baseline forecast?
Yes, I use 95% confidence intervals in my estimates.
Okay, well that answers that nicely. Thanks for that, Rami. Do we have any more questions maybe in the Zoom chat? Can I see? I can't see any. Can anyone else see any questions that need?
I don't think anything new came through in the Zoom chat. Let's give everyone like a minute if they want to unmute themselves and ask a question. You have the time now. Otherwise, we'll close. So let's wait. So. It doesn't seem like it. So I think we should finally close here now. Thank you for to all the attendees for your questions. Thank you very much to all the speakers for taking the additional 20 minutes and replying to the questions. And yeah, before, oh, someone speaking? No, that's just someone hasn't unmuted themselves. We will send out an email tomorrow with also a feedback form for you to fill out, and probably also a link to the recordings. And if you have any questions, just drop us an email. It will be on the Eventbrite page. So if you need access to any of the slides or anything else you have, really just write us an email. Yeah.
Also, we'll make the recording available and give you the details via email at some point in the next week.
Great. Okay, thank you very much, everyone. Great, thank you also to Mark Gillett for joining us today.
Thank you.
And yeah, see you in a year in Loughborough.
Thanks, everyone.
Thank you.
Bye.